Hey everyone, my name is Hassan and I'm a Comp 444 student offered at Athabasca University, a course on robotics, and I'm here to present to you my final project in the course. So this is Sparky. It's an autonomous robotic car that uses an ultrasonic distance sensor to be able to scan the environment around it and be able to make locomotion decisions as to where to navigate and avoid obstacles in the process. So before I go into the demonstration of its functionality, I want to talk about some of the behaviors that I've coded into this little guy here. So right off the bat, when Sparky's fired up, he sets the servo to 90 degrees, and that makes the ultrasonic distance sensor face directly forward, and he takes a distance reading. Now, if there's nothing ahead of Sparky, he starts moving forward. If there is something in front of Sparky, or if while he's moving forward he comes across an obstacle, he stops moving. He first moves the servo to the 0-degree position, which moves it left and takes a distance reading, and then he moves the servo to the 180-degree position, which is looking right, and then takes another distance reading, and then makes a decision as to where to turn and what to do in order to get out of the pickle that he's found himself in. So if when he looks left and right, he finds no obstacles on either side, what Sparky does is he turns right. If Sparky finds obstacles on both sides, what Sparky does is he turns all the way around so that he can head back. If Sparky finds an obstacle on the left side, he turns right. And likewise, if Sparky finds an obstacle on the right side, he turns left. Also, when Sparky is changing direction in that he's either turning left, turning right, or turning all the way around, he sounds at various tones through a piezo buzzer. So the turning tone is the same whether he's turning left or right, and then I have a separate tone defined for when he's turning all the way around. So I'm gonna hop into the demonstration aspect of this video now, and after that I'm gonna talk about some of the challenges I faced along with how I put them together. And this video is actually a supplement to the report I'll be publishing in my weblog on the landing. So if you'd like more information on my project, please be sure to check that out. So let's hop into the demonstration now. Hey everyone, I just want to talk about a problem I encountered right as I was about to start filming the demonstration aspect of this video. So I use an ultrasonic distance sensor mount to attach my ultrasonic distance sensor to my servo, and I was doing so by means of the hole that's in the servo. So I used a screw that was included with the servo to secure the mount to the servo. Over time, this screw came loose, and so my ultrasonic distance sensor wouldn't move left or right as the servo moved. So naturally, I grabbed a screwdriver and tried to tighten that screw, but the screw was spinning freely in place, so the hole has become stripped, and I was no longer able to tighten that. And so that'd be a huge problem, right? I can't look left nor right. That kind of defeats the whole functionality of the robot. So the way I went about fixing this is I took one of the included servo attachments, and luckily the holes that are opposite to one another line up perfectly with the holes that are on the ultrasonic distance sensor mount, and that will allow me to mount my ultrasonic distance sensor mount to the servo more securely. And it'll be forced to rotate because there is some threading inside here that lines up with the servo, and that'll force the ultrasonic distance sensor to move as the servo moves. So that's how I fixed it, and on to the demonstration. And just like that, the problem is now resolved. All right, everyone, so here Sparky is all fired up and ready to go. As you can see, he's not currently moving anywhere, and the reason for that is I haven't switched off. So instead of using a traditional switch, I opted to use this jumper clip that came included with the Adafruit motor shield. This jumper clip allows you to use one power source so that you can have batteries plugged directly into the motor shield. And then the motor shield then passes power to the red board by means of this jumper clip. If you pull this jumper clip and are using only one power supply that's directly plugged into the motor shield, the red board doesn't get power, and so the robot doesn't have a brain, and so he stops. He doesn't do anything. And so the reason I didn't use a traditional switch is if you have a rogue runaway robot, it can be incredibly difficult to be able to first reach for the switch and then be able to switch him off because you'd have to fidget with it. And so this arrangement's a lot easier because it's much quicker and simpler to pull a clip versus reach for a switch and fidget with it to power it down. Now I have the servo motor looking right because that's the state that I powered him off in, and now I'm just going to throw in this jumper clip and just demonstrate. So what we expect is the servo motor to be at the 90-degree position for him to look straight forward, scan the area, and then start moving. So here we go. There you go. So he starts moving forward because it's clear, looks left and right, decides to turn left because the area to the right has obstacles, turn left again. So I'm to his left, so therefore he didn't turn towards me. There we go. Both areas were clear, so he turned right. And here we are in a separate room. So I wanted to give Sparky a little bit more space to navigate, and I wanted to put him in a situation where there's an obstacle directly in front of him, to his left and to his right as well. So let me just pop in this jumper clip and send him on his way. There we go. He turned all the way around. So let me just follow him. He's headed directly for that corner over there. Okay, so he senses the couch, decides to turn left. Senses the couch again. Now I'm in his way. Let me just get out of his way, or a little too late for that. But anyways, he turned left because that was the most clear path. Detects the exercise bike and turns left. Now he's headed for the couch again, so let's see what he does. Decides to turn left because he can sense that there's obstacles there. Let me just get him to stop on my own. And he's headed for the stairs, so I better tell him to head the other way. There we go. So that is Sparky in action, everyone. I want to demonstrate the piezo buzzer now. So I'm going to put him on some jack stands and try to give you guys a listen. So, he's still doing his thing. Hasn't crashed yet. So anyways, that is my final project, Sparky, the autonomous robot. And he's headed for the stairs. Oh, good. He detected the couch. Anyhow, everyone, I hope that this demonstration is adequate to demonstrate its functionality. And onto the piezo buzzer we go. So here we are again. I've got Sparky on some jack stands by means of some wheels. And that just elevates him so that he's not on the ground. In his mind, he can think he's moving, but he's not actually going anywhere. And I just want to demonstrate the functionality of the piezo buzzer. I'm not sure if you could quite clearly hear the piezo buzzer in action in the previous videos. I know I could, but just to make sure that everyone heard it, I'm going to place my microphone close to the piezo buzzer while the robot does its thing. So to simulate obstacles in front and to his left, I've set up some props and I have him facing the wall. So I'll start by playing the tone that plays when Sparky is turning either left or right. In this case, he's turning right because there's an obstacle to his left and directly in front, but the tone would otherwise be the same if he was turning left. So let me just fire him up here. So that's the turning tone. And let me just demonstrate the backing tone. There we go, everyone. That is the piezo buzzer. So that concludes the demonstration aspect of this video. For those of you who are interested, I talk about how I built Sparky and some of the challenges I faced along the way next. So if you're interested in that, please do stick around. The rest of you, I thank you so much for watching, and I wish you all the best in all your future endeavors. I ordered this chassis kit online just to save myself the hassle of having to create my own. Plus, the SparkFun Inventors Kit only comes with 2 wheels and 2 gear motors, so I would need 2 more anyways of each. So, for starters, we have 4 wheels. We have 4 gear motors. It comes with a battery holder, some screws and stuff, and coder just to put everything together. And we have an instruction manual. Besides that, we have the chassis itself, and this chassis is a 2-piece chassis. There's the upper and lower, so it's going to have 2 pieces to it, and that's the chassis kit. Next, we have the Adafruit motor shield, and this is what I'll need to be able to drive my 4 gear motors. Comes nicely packaged to prevent it from any damage in shipping. So this is what the motor shield looks like. You can see that the header pins are not attached, so they include header pins on the side that will need to be soldered, which shouldn't be too difficult. And then we also get a little jumper clip in case we want to alter our power source. These are some other parts that I'll be needing. So we have the breadboard. We have 4 lithium-ion batteries. They're 18650 rechargeable. We have an ultrasonic sensor to act as our vision. We have an ultrasonic sensor holder. So this kit comes with a bunch. I'll only be needing one, but you can see that there's a screw hole on the bottom to attach it to a servo, and that makes life a little bit easier as well. Okay, and then we have 120 jumper wires that come in configurations of male to male, and female to female. To power my robot, I'm going to be using a battery holder with 18650 rechargeable lithium-ion batteries. I'll most likely be going with 3, so this battery holder kit comes with different configurations. 1 battery, 2 batteries, 3 batteries, or 4, with wires already soldered on, so that makes life easy. Okay, and that's how we're going to be powering the robot. I have a piezo buzzer, and last but not least, I have a micro servo. To solder the header pins to the Adafruit motor shield, I started by breaking off appropriate length header pins from that one strip that they included and sticking them into the breadboard, and that just holds them securely. Then what I'm going to do is I'm going to take my Adafruit motor shield and I'm going to slide it on top of the breadboard so that the header pins are going to appear in the appropriate slot on the Adafruit motor shield. And then from there, it's very simple. You just solder. So the process was a bit tedious, but I finally got it on. Now you can see just faintly the header pins are visible, and so in all the areas where the header pins are visible, we're going to be soldering so that we make a solid connection, and that the header pins will now belong permanently to the Adafruit motor shield. So I'm currently soldering right now, and you can see I've done an okay job on this side, but I've encountered my first problem. As you can see, the 5-volt and the ground pin are now joined together because of excess solder. So I don't readily have tools available with me right now, so what I'm going to try to do is heat that solder up and use a razor blade to remove the excess. So once it's heated, come in with a razor blade, try to remove the excess, and try to remove that so that they're not short-circuiting. Also, as with anything, be very careful. If you are going to be soldering, do so at your own risk. Soldering irons are very hot. They can cause significant injuries, and there's a fire hazard, of course, involved as well. So be very careful, do so at your own risk, and take your time with it. And just like that, we have header pins on our motor shield. Perfect. Now, this can be effectively stacked on top of the breadboard and made use of. So the gear motors that came with the chassis kit did not have wires soldered to them, so that's another step that I had to take. So as you can see, the wires have been soldered onto this, and so this is how the gear motors came. Just, they got the gearing system, of course, the motor itself, and then just the 2 leads. But they did come with wires, so they provided the wires, and all you have to do is solder them together. Alright, so let's touch upon some of the challenges I've faced so far. So right off the bat, I encountered my first hiccup when mounting the motors to the chassis. The motors are secured to the chassis using these two T-shaped pieces. Basically, one goes on the outside of the chassis, one goes underneath the chassis, well, it passes through the bottom side. And then you just pass two screws through the motor, through the T-shaped pieces, and you fasten a nut on the other side, and that's what securely holds the motors in place. Yeah, and they're pretty sturdy. When I was using the T-shaped piece for this motor here, which is the right front motor, it decided to break on me, and I hadn't even tightened the screw that much, so I'm led to believe that perhaps there was some manufacturer defect at play. I know that this is a fragile material, so I was being very careful, but the screw still caused the T-shaped piece to break. And going back and looking at some of the reviews online, I saw that I'm not the only one who's encountered this problem before. Now, this is a huge problem, right? Because without being able to secure the motor in place, we wouldn't be able to have a right front wheel. It would move all over the place and it wouldn't be held onto something. So I used hot glue and a little bit of Gorilla Tape to come up with a fix. And the way that I did it was I used the hot glue in excess to ensure that a secure bond is formed, and a little bit of Gorilla Tape just to hold the motor in place while I applied some of the hot glue. And so the combination is very sturdy. That motor's not going anywhere. There's no vibration, there's no moving around, there's nothing. So that was my first challenge. A second problem I faced was when I mounted the breadboard to the chassis. So this is the top half of the chassis. And when I initially mounted it, I just used the screw and then a nut on the bottom to fasten the breadboard to the chassis itself. But the problem was, because the breadboard was sitting flush with the chassis, I was no longer able to plug in a USB cable to be able to interface with the breadboard. Now that's a problem, of course, so what I did was I installed a second nut between the breadboard and the chassis to act as a spacer. So that gives us just the right amount of room that we need in order to be able to plug in a USB cable and interface with the breadboard. So that was a quick fix. A third issue I'm currently facing is the fact that I did not use stackable header pins on the Adafruit motor shield. So if you recall, the Adafruit motor shield does not come with any header pins pre-installed. They supply them on the side. In fact, this is what they look like, and you have to solder them yourselves. Now, of course, this is just to allow the Adafruit motor shield to be able to plug into the breadboard or an Arduino board. It doesn't allow you to plug anything else in. And, you know, I can demonstrate these other holes that are present here. If we were to plug a jumper wire directly into one of the holes, that's very flimsy and like it just comes out so easily. So that's a problem. I didn't want to have to go back and unsolder all of this and then resolder some header pins in. First of all, I need to order some header pins that are stackable to be able to do that, wait for them to arrive, and then solder. So what I'm going to be doing in this case is I'm just going to take some extra wires, I'm going to cut off the tip, and I'm going to solder them to the appropriate pins. And I'll show that after I'm done, but that should solve my problem. Alright, so here's how she currently sits. She's fully assembled, and I have completed soldering. So for soldering, I had to solder 5 wires total. I used digital pins 2, 13, the 5 volt, and the ground for the ultrasonic distance sensor, and then I used digital pin 10 for the piezo buzzer. And for ground for the piezo buzzer, I'm just using one of these servo pins to ground the piezo buzzer. And I mounted the piezo buzzer at the very back. Not sure if you can see, there are some holes in the chassis, and those holes are actually perfectly sized to hold the header wires. So it's secured quite robustly. So the piezo buzzer is mounted at the back there. I used double-sided tape to mount my servo to the chassis, and it's quite sturdy. I used the ultrasonic distance sensor mount to hold my ultrasonic distance sensor, which I mounted using some black tape. And the reason I used black tape was just because I wanted to be able to take it apart. If I used hot glue, perhaps the bond may be too strong. I didn't want to risk breaking components if I do decide to take it apart in the future. So tape works well for that. And so just a little bit of black tape, and I used some jumper wires to be able to connect everything together. Of course, the wires alone on a lot of these components were not long enough, so I had to use extensions, and sometimes you see some of this extra wire hanging out. I'll clean that up in a bit here, but the excess wire just runs through the middle of the chassis. And to mount the mount to the servo, I used one of the screws that came with the servo. So that's how I secured that. And that's the robot. I mean, everything's put together. I used the hardware that came with the chassis, including the screws to mount the red board to the chassis, and the Adafruit motor shield just mounts directly on top of that. So thanks everyone for checking out my project. This has been a lot of fun, and I'm actually going to expand on this project. So for the future, what I'm planning is to add some remote control capability, perhaps build a drone as well that's able to navigate itself, an autonomous drone, and maybe have the two communicate so that they can, just kind of navigate the world together. That'd be really cool, but I'm excited. I don't plan on giving up robotics after this course. No, this is just the beginning. I've always loved robotics, and I can't wait to see what the future holds. Thank you very much, everyone, and I wish you all the best in all your future endeavors.